Hello guys, and welcome back to Khaliltronics. In today's video we're in the last part of the limits. So we are in limit to the infinity or horizontal asymptote. So this part is very interesting and very easy. So you can easily find the answer by near looking. No need to confirm if you like, otherwise you can use the numerical method to compose. So that's why it's so easy and interesting. So in this method we are trying to find the limit to the infinity. So we have generally we have three cases. So initially what happens if the function it goes to the further and further out of the left or right? Well, it depends on the function, but how the answer can be discovered by the following independent variable to take the increasingly large positive value and give an eyes to the output. So basically we have three cases. Here are some basic facts and some generalized that will be sufficient to evaluate the most limit to the infinity. So this is a three case. Let me change the fan. Okay, so this is the three cases. We have case 1, case 2, case 3 respectively. So what you need to do if you the limit given as infinity, what you need to do is to just focus on the denominator of the function and then a numerator at the same time. So the numerator is n of s and denominator is what d of s. So by looking at the numerator or denominator to see which one is greater, the highest power of the highest degree of the power. Like if you on the numerator you have the higher degree that we have is what is 3, and the higher degree that we have on the denominator is what is 2. So we have to look which one is grow faster or which one is higher. So in this case we have limits x goes to infinity 5x cubed then minus 2x squared plus 7x minus 13 all over 2x squared plus 7x plus 2. So which one is greater? Actually the numerator is greater because it has the highest power. It has 3 degree of the x, it is 3. So the highest power, like we have let's say we have 5x at the highest power cubed all over our 2x squared at the highest power. So the highest power numerator has the highest power, so our numerator is greater than the denominator. So if that's the case, we can say it is infinity. The answer is equal to infinity. So likewise for the case 2, because that the highest degree of the numerator is greater than or grow faster than the denominator. Here we have 3 as the highest power, the denominator we have 2, so a numerator is the greater. So we can say if numerator is greater than denominator, we have infinity. So that's why I wrote infinity. And then case 2, if a numerator is less than the denominator, n of s is less than d of s, we have 0. So what I'm trying to tell you is that if you have here we have limit x goes to infinity 11x squared plus 2x minus 9 all over 3x squared minus 4x 3x cubed minus 4x squared minus 5x minus 9. So here on the numerator side we have highest degree as 11x squared, and then denominator we have 3x cubed. So we have the highest degree as x cubed, so denominator is grow faster or is greater than the numerator. So in this case, if that's the case, is equal to 0. And the last case, if the highest degree of the numerator is equal to the highest degree of the denominator, that's dns is equal to dn. So the answer should be limit x, the answer should be equal to what? The coefficients of the degrees, the highest degree. That's, you can see O over V of the what? ns, sorry, I mean A of what? ns all over V of what? D of s, which is what? A over V. So like in this case, we are having limit x goes to infinity 2x squared plus 7x plus 9 all over 5x squared plus 2x plus 5. So here the highest degree is what? We have 2x here, and then the other, in the denominator we have what? 5x squared. So they are sharing the same equal degree of the x. So here we have square, here we have square, so they are the same. So you have to just take the coefficients. Since the highest degree is the same, we have to just take the coefficients, and then the coefficient, if that's the case, the answer is going to be equal to what? 2 over what? 5, as we take the coefficients of the what? Highest power. So this is how to get the limit to the infinity. It starts by near looking, you can find the answer. Otherwise, you can use numerical method that I'm going to show you now. So I'm going to take case 1 and take the same question that I have solved using infinity O0 or 2 by 3 to see if the answer is going to be correct or not. So let's take question number 1. Let's take case number 1. Case 1. So in the case 1, we are having limits as what? X goes to what? Infinity of what? 5x cubed minus what? 2x squared plus what? 7x minus 13 all over, here is 2x all over 2x squared plus 7x what? Plus 9. So by near looking, the degree of the numerator is greater than the degree of what? Denominator. Here we have raised power 3, here raised power 2. So as we already know, is equal to what? Infinity. So we are going to prove, we are going to use numerical method to find the given answer. So what you need to do first, so as it's very easy, what you need to do is to just what? Find the highest power. So the highest power is what? X raised power of 3 is x raised power 3. So you divide through x raised power of 3 and see. Okay, so if we divide x raised power of 3 and see which what we can get. So the highest degree as from this given question is x raised power of cube, as you see right here, is x raised power of what? 3. So since x raised power 3 is the higher of the degree, so we divide this through by so each part we divide this through by x raised power 3. So we can say 5 raised power of 3 over what? X power 3, then minus 2x squared over what? X power 3, then plus 7x over what? X power 3, then minus 13x power what? 3. So, and likewise for the denominator, you have to divide through each term, you have to divide by s cubed. So here we have what? 2x squared by what? S cubed, I mean, plus what? 7x all over what? X cubed, and then minus 40 plus 9 all over what? S cubed. So here is what? Limit at what? S goes to what? Infinity. So here is what x cube by x cube, this one goes with this one, so we are having 5, and then here I have minus 2 as coefficients, x cube, x squared divided by x cube, I have what, 1 over x, so we have what, 2 by what, x, and then for this one we have s divided by s cube, so we remain x square at the denominator, so we have plus what, 7 over what, x square. For this we have what, 13 by what, s cube, and then for the denominator we have what, 2, here is x square by x cube, we have 2 by what, x, then plus 7x by x cube, we have 7 over what, x square, then plus what, 9 by x cube. So since you distribute x, you divide through by x cube to the each term, so you are to look, and then our infinity, our limit is what, limit as what, h goes to what, infinity. So what you need to understand, like if you have this limit, x goes to what, infinity of what, 1 over x, let's see, 1 over x. So by substituting x to be equal to limit, you will say this is equal to 1 over what, infinity. So 1 over infinity, 1 over infinity is what, you have to be very careful. 1 over infinity is going to be equal to infinity. Definitely 1 over infinity is going to be equal to what, infinity. So sorry, I mean it's going to be equal to a, 1 over infinity. If you have x to be equal to infinity, then you have 1 over x, you have to substitute x to be equal to what, infinity. So I replace x 1 over what, instead of x I put infinity, so 1 over infinity, meaning like 1 over, let's say infinity 1 rest, let's say 20 billion, or what, 20 trillion. It's like approximately to infinity, so this is equal to what, 0, approximately equal to 0, so it's not infinity, I mean I'm trying to say 0. So 1 over infinity is 0, you have to put this on your mind. So 1 over infinity, like if you are dividing 1 by the largest number, that's infinity, so it's going to give us 0.000000000 till infinity, so it's approximately equal to what, 0. If it's 0.0000, it will just what, 0. If that's the case, is 0, so we can say here is going to be equal to what, 0, since we have 1 over x, here 1 over infinity, here 1 over infinity, 1 over infinity square is going to be equal to what, 0, here is going to be equal to 0, here is what, 0, here is what, 0, we have x, here is what, 0. So if that is the case, we have what, is equal to 5 minus 0 all over what, 0, so we have 5 over what, 0. So 5 over 0, remember we have 0 on the denominator, so you know it's what, undefined, which is what, infinity. So the answer is what, infinity. So if you have what, numerator, n of s is greater than denominator, so what, this is what, infinity. Likewise, let me take the second question. The second question is example 2. So the second question is 11 x square plus what, 2 x minus 9 all over what, 3x cube minus 4 x square minus 5x minus what, 9. So as you see, the what, degree of the denominator is greater than what, numerator. So in this case we are having, we know already if this numerator numerator is less than denominator, we are having what case 2, which is what equal to 0. So we are going to find it out as limit x goes to what infinity. So still we are to divide through by the highest power of the x. So we have x cubed as the highest power, so we are to divide through. We have 11x square over what x cubed plus what 2x over what x cubed minus 9 over what x cubed all over what 3 what here we have what x cubed over what x cubed minus 4 all over what 4x square over x cubed minus 5x all over what x cubed minus what 9 all over what x cubed. So here we are having a limit at what x goes to what infinity. So still same procedure, we know limit as x goes to infinity of what 1 over x is equal to what 0. So if you substitute, we say 1 over infinity 1 over x before limit s goes to infinity 1 over x is equal to replace infinity to be equal to x. 1 over infinity is equal to what we know is equal to 0. So we are substitute this in our normal equation. So here we are having 11 over x. Here we are having 2 over what x square. Here 9 over x cubed all over. Here is what this go with this, we have 3 and then minus, here we have 4 all over what x, and then minus 5 over x square minus 9 over what x cubed. So since if this we have x right here, this is going to be equal to 0, likewise 0 0. So at the top we are having 0, and then here we have 0, here we have 0, here we have 0. So 3 minus 0, so 0 over 3, which is equal to 0. So as you see, we get 0 by 3. 0 by 3 is 0. So if the numerator is less than the denominator is, we are having 0. So if you like, no need to confute. So if you have such case, this is the numerator is higher than the what degree of the what numerator, so it's just 0. That's case 2. So the last case, if they have the same power, so it's going to be the coefficients. So the last one, that's case 3, we are having 2x square plus 7x plus 9 all over 5x square plus 2x plus 5. So the same procedure to be applied. Like if this is the case, we are going to solve it by near looking. We can just say the coefficient of, since the first power are the same, they have 2x square as well and 5x square, they are the same, so we just take the coefficient, which is what 2 over 5. So the answer is 2 over 5. So let's compute it and see. The highest power is what x square, so we have to divide through. So we can say 2x square by by x square by x square plus what 7x by what x square plus 9 by x square all over what 5 by x square by x square plus 2x by x square plus what 5x by x square. So here x square goes x square, we have 2x square goes x square. Here there is x, so here going to 0, here going to 0, here is going to 0, here is going to 0. So we left with 2 minus 2 plus 0 plus 0 all over what 5 plus 0 plus 0. So we have what 2 plus 0, 2 all over 2 plus 0, 5 plus 0 plus 0, we have 5. So the answer is going to be 2 by 5 as we said. So this is the final solution. if you have the same coefficient, if you have the same power, just take the coefficient. This is the end of calculus concerning or consistent integration, limit and differentiation. So don't forget to subscribe, give a like and comment. Also click on bell icon. If you want to watch the previous video, you can go to our playlist on our main channel and download and see. Thank you for watching. My name is I'm Khalid Tronics. See you in the next video.